Hi, thanks for joining me today. My name is Erin Miller. I am the Director of Performance and Reliability Engineering at MarkLogic. And today I'm going to be talking about resource utilization and the Data Hub framework. So I'm going to be talking a bit about capacity planning, a little bit about understanding how different components in the Data Hub framework impact your system resource utilization and thus the performance of your application. So the first thing I want to say about all this is that if you don't want to deal with this complexity and all these independent components and worrying about how much RAM you have and if you've got enough CPU and how many IOPS you're doing, we have a fully managed Data Hub service available for you today on both Azure and on AWS. We'll take care of all this stuff and you just worry about writing your application. So you might want to check that out. Definitely, if you're not ready to get there yet, certainly kick the tires, see what it's like, and get a sense for how it works. However, if you are looking for information about resource utilization and you're running either on-prem or you might already be running in the cloud, but with your own Data Hub framework, what I'll be talking about today will help you kind of understand how to do some planning and how to understand how the different components of Data Hub impact your system utilization and your performance. So here's our Data Hub platform. What I'm going to be talking about today is just over on the left side of this slide here, where we talk about loading data as is, the ingestion process. And we're also going to be talking about the process of curating your data, of getting it from that as-is state into a harmonized or curated state, so that your various downstream or upstream silos of data can kind of be combined into a standard format that you can then use to write applications. So I'm going to be focused on mastering, governance, semantics, metadata, basically everything you need to do to get it into that curated state. So I always like to talk about balance. In performance engineering, we're always looking for the bottleneck, and that's always our first question. If somebody says it's running slow, it's like, okay, what's your bottleneck? Which thing are you running out of? Which resource is scarce? So, with MarkLogic, the way that I think about it is it's really RAM, CPU, and IOPS, your disk reads and writes. And so if you can kind of keep all of these things balanced, you don't want to have like a huge amount of RAM but not enough IOPS, things won't work well and you won't actually be using that RAM. So the goal is to try to make the best use of all the system resources that you've got. And hopefully what I'll talk about today will help you a bit, so that you can reason about the best way to do that for your application. All right, I want to talk a little bit about behind the scenes stuff, the stuff that the Data Hub framework kind of hides away so you don't have to worry about it. That's what I want to talk about a little bit, so that you can understand what's actually happening behind the scenes when you're running through these various steps. So the first thing I want to talk about is an ingest step. And when you're running a flow, it's usually step one. Is like, get some data in there. We want to basically bring data sources, and they might be multiple data sources that you're bringing together into the Data Hub. So I want to talk about what happens behind the scenes as you do that. So the Data Hub will send the document to a MarkLogic app server. The document is loaded into an in-memory stand. And if you recall, the segments of our data on disk are called forests. Forests are made up of individual stands, basically smaller containers of data. And so the in-memory stand is a special stand that every forest has, where the content is basically stored in memory. And at the same time, when a document is inserted into the in-memory stand, a transaction is written to a journal. We are an ACID database, so if you lose that in-flight transaction, we want to be able to replay it so that if your system goes down, we don't want to lose the in-flight transaction. Periodically, you'll see the in-memory stand get flushed to disk. So you'll see a larger series of writes, and it'll be kind of choppy. Sometimes we have new DBAs or folks who haven't worked with MarkLogic before, and they're like, what's going on? It's not doing anything. And then all of a sudden you see all these writes. Yes, that's the in-memory stand being written to disk. And then as there are more and more in-memory stands being written to disk, we go through this process of forest merges. Merges are just an automatic background process that we use to reclaim disk space and optimize your indexes. And so everything we're doing in this phase is being written into the staging database. Thinking about resource utilization with ingest as is. So the biggest and most important thing to keep in mind here is you're doing lots and lots of IOPS. You're doing a lot of disk reads, a lot of disk writes. So that's important. We're also using memory, the in-memory stand, and obviously all of the database caches that get populated as the documents are inserted. We're using CPU, and this will depend upon your ingest mechanism. You might be using, for the data hub, either MLCP or the DMSDK, which is our Java-based client to ingest data. So that can vary. You will definitely should expect to see a significant nice percentage in your CPU, and that represents just the database merges, that background process I was talking about. It's also important to remember that if you're doing a custom hook or you have a special transform that you're using on ingest, that can lead to potentially high CPU utilization depending on what your code's doing. So it's an important thing to keep in mind as you're deploying your ingest. All right, so moving on from that ingest into taking the as-is data and making it curated data. So the process of this we call harmonization, and basically what's happening here is we're reading data from the staging database. We're doing various things, applying transformations and steps, which we'll be talking about momentarily. And then the final data gets inserted into the final database. When you're running a harmonization flow, you're going to be inserting batches of data into that final database, and all the ingest as is considerations apply. You want to be thinking about your IOPS. You're going to be doing lots of IOPS, and in this case, now you're reading from staging as well. So there's a lot going on here. All the other stuff that happens in the background also happens during harmonization. Another important aspect of harmonization is the envelope pattern is applied. So we are adding metadata to your documents that describe the documents and where they came from. Potentially, you're also doing governance, which we'll talk about in a few minutes. So this is adding triples. You're adding triples to your database, and so it's important to remember that semantics queries impact memory utilization. So if you are doing lots and lots of semantics queries as part of your harmonization work, you should really consider separating out your evaluator and your data nodes. And basically all that's doing is separating out the storage from the compute layers here. Definitely an effective way to utilize particularly memory during semantics queries. So let's talk about running flows. We've already talked about running the ingestion step. Now let's talk about a mapping step. What is this mapping step? Well, all we're doing in this case is we've got some predefined entities that we've created, and now we want to map the data that we've ingested to those entities. An example of this would be, okay, in my staging data, I have an element that's called L name, and that's the last name for a person in this defined entity. So I want to map those. There's lots of different ways to map. There's basic mapping that you can do in the UI. There's also a template-driven extraction that you could use to apply templates to your data and do the mapping that way. So all sorts of different things you can do there. The outcome of this is that we write new documents and triples to the final database. Matching steps. Matching is step one, or part one, of a data mastering process. What's data mastering? Well, in my database, I have a J. Smith and a John Smith. They have the same birth date. They actually turn out to be the same person. I want to merge them into one record. That's just kind of the idea of what data mastering is. The matching step is step one. It's identifying which documents to merge. And it's not doing the merging yet, it's just doing the identification. Tons of options here, lots of different algorithms, lots of different performance characteristics, and particularly if you're writing your own custom matching algorithm, definitely performance test it, because there's multiple things that can happen here, and particularly both in terms of CPU and in terms of document locking, which we'll be talking about momentarily. Those are important things to keep in mind as you're doing your matching. Your merging step is the second part of your data mastering step. So now you've identified which documents you want to combine and you want to merge them together, and the output of this step is it writes the data to the final database. This is a non-destructive operation. This is not overwriting anything in your staging database. It's combining the records and putting the new one into final. There's also a step called mastering. It might be called smart mastering in 5.2, the Data Hub 5.2. So what this is doing, this is combining the matching and the merging steps into one process. So if you're running with a large number of documents at scale, it's best not to use this kind of step. It's best to use the multi-step process, meaning you have a matching step and a mastering step, the two steps I described previously. The reason for this is if you have a large number of documents, you can run into potential locking issues with a single step, and that can really slow down your flows. If you're running into this, you would be able to identify that. You'd be able to see errors in the error logs, particularly if you have debug logging turned on. You'd see locking errors in addition, or warnings, because we'll go through a warning and a retry process if we have a lock conflict. We won't just deadlock and call it a day. You go through a retry process. So you would see those retries showing up in the error logs. This would also slow down your flows, so potentially significantly. So you'd see a much longer duration to complete your flows, and you'd see lower utilization, CPU utilization, which is what we are always looking for when we have locking conflicts. All right, now I want to talk about the system utilization resources that are used when we're running these different steps. So what happens with our IOPS? We're doing, in the mapping step, a lot of reads and writes, both to the final database and to the staging database. You are reading from staging, writing to final. Matching requires a large number of reads as well. It doesn't write new documents, though. It is writing in that it's not doing the merge step and then writing it out. It's writing lists of URIs that need to be merged. So it's a lower impact on writes for matching. But it's a large number of reads, obviously. Merging, the merge step, requires both reads and writes, and the output of that is that the new documents get written to final. So, keeping in mind you're reading multiple docs from staging, writing a single doc to final per operation. Memory is an area. So IOPS, we know we're going to be you'll have a significant number of IOPS going through this process. With memory, this is one of those fuzzy, it depends on transformations in particular. So are you doing custom hooks with a large number of semantics queries as part of one of these steps? Maybe even your mapping step, could be matching step. Definitely you want to consider separate E&D nodes and provide lots of RAM to all of your nodes, but particularly your E nodes, the nodes where you're doing that query evaluation. CPU, so both matching and merging can use significant CPU resources, and it depends on the algorithms. They're out-of-the-box algorithms. You can write your own custom hooks and do your own sorts of custom algorithms. It's just something to keep in mind as you're doing your performance testing, and I always recommend performance testing your various flows so that you know what you're going to be doing, basically, to get to the point where you are able to serve your application up. So the other thing to think about here in terms of CPU, all these steps have configurable number of threads. So if you have a priority conflict, like you need to get an ingest done 2 hours, but you're also running a long-running, merge job and you don't want to stop it, or you know that you're going to be running a matching job at the same time, and you don't care if that takes longer, you can prioritize different steps by configuring those with a larger number of threads. So you could increase the threads for your ingest and decrease the threads for your merge step, for instance. Definitely doing performance testing at scale is always your friend. For sure, it will help you create a model of how your specific code base impacts system utilization. All right, I want to talk briefly about governance. So when you enable governance on documents, this is basically provenance and lineage. And what it is it's metadata about the documents themselves. So we create XML metadata documents that we insert into the jobs database. It's called provenance metadata. We are also generating triples, which maintain and describe the relationships between these documents and the final data record itself. And when these are enabled, they're enabled for the lifetime. And so every time you update a document, that provenance metadata also needs to be updated. So you're going to be writing to the jobs database and the final database. If you enable this, it's enabled, I believe, coarse-grained by default. If you enable it as fine, it could potentially lead to a very large number of documents, particularly in your jobs database. So keep an eye both on your available storage space and your IOPS for the jobs database. If you're seeing that doing all these writes to jobs is actually starting to impact your other databases, you might want to consider having the jobs database on a different disk device, or basically managing your storage based on that. A word here about capacity planning. So, storage space. Remember that you're ingesting data into the staging database, and then when you harmonize it, it gets inserted into the final database, but it doesn't get removed from staging. There's no purge operation. So you might want to consider a tiered storage strategy for retiring older or unneeded documents. Or some kind of cleanup strategy. So you may want to keep all of those documents, in which case a tiered storage strategy is a better approach. You could potentially even have offline forests in your staging database, or you could periodically clean up or purge those documents from staging. Just something to keep in mind as you essentially have multiple copies of data in these various databases. The other thing to keep in mind, as your content grows, you're going to need more RAM for forests. And this is for caches and indexes, as well as available RAM for queries. Particularly if you're doing semantics queries, the Data Hub framework itself does some semantic queries, so you need to consider that as well. So as you scale up, you'll find that your CPU utilization may increase. And I always think about this in terms of, you're doing a matching step in a database of 1,000 documents, and that's super fast. But when you try to run that matching step on 1 billion documents, all of a sudden things get a lot slower, and my CPU is at 100%, and I don't know what I'm doing. And it's like, okay, this is another moment where it really makes sense to performance test and make sure that you have the CPU utilization, so that you have a model of how your CPU utilization will increase. So final thoughts. Basically, the Data Hub service will solve many of these problems for you. You won't have to worry about IOPS. You won't have to worry about, do I have enough RAM to get through this? We can scale out for you as needed. So what I would suggest is let us focus on performance and capacity, and you can focus on solving your business problems with the Data Hub. So this is, again, a great opportunity to try it out. I highly recommend doing that. I'd also just like to say that I would love it if you would reach out with questions or comments. One of my favorite parts every year at MarkLogic World is just talking with different customers and hearing your questions at the end of presentations. So this year, you're in my house, and it's a little bit different. So in this case, please feel free to email me. I'd love to hear questions and talk more about any comments you have or any concerns as you're trying to do this planning. And most importantly, I just really want to thank you for taking the time to spend this time with me and understand more about how the Data Hub works internally. Really looking forward to hearing your questions, and thank you again for your time.